Welcome, curious minds, to another deep dive.
Great to be here.
Today, we're tackling a topic that might seem a little paradoxical.
Mm-hmm.
The very climate crisis we're trying to solve is now, well, surprisingly impacting the clean energy solutions we're building.
That's right.
We've got some fascinating sources, mainly from UN News and some insights from Envision Racing, too, that really help us unpack this. It's quite complex.
It is.
You might instinctively think, okay, we just need to build more solar panels, more wind turbines.
A usual solution.
Exactly. But as we'll explore, it's far more nuanced than that. We need to make sure these green energy systems can actually withstand the very forces they're meant to mitigate.
Yeah.
So this deep dive, our mission really, is to look at how climate change is already shaping and sometimes threatening renewable energy production.
And the solutions.
And crucially, what groundbreaking strategies like this thing called climate intelligence are emerging to make our future energy resilient.
That's right. And, the drive towards renewable energy is accelerating at an incredible pace, which is, well, it's truly fantastic news.
It really is.
However, this rapid expansion also casts a spotlight on a critical vulnerability.
Okay.
Much of our clean energy infrastructure, because it was designed based on past climate patterns, now faces a future that is, well, anything but predictable.
Right. Not stable anymore.
Exactly. So this deep dive will get into the what and the why behind these challenges, but also showcase some really innovative solutions already taking shape.
Okay, let's unpack this then. The good news first. The race toward renewable energy is absolutely accelerating.
Definitely.
New data from IRENA, the International Renewable Energy Agency, shows global renewable capacity grew by a record 585 gigawatts in 2024.
Wow, that's huge.
It's massive. To put that in perspective, that's like adding the entire generating capacity of, say, France in just 1 year. It represents over 90% of all new power added worldwide and the fastest annual growth rate in 2 decades. It really feels like we're seeing a major shift.
It's compelling seeing this monumental growth. Yet 2023 really marked a significant turning point.
How so?
Well, that year, global temperatures soared 1.45 degrees Celsius above pre-industrial levels.
Right, that record heat.
Yeah, and we also had that major transition from La Nina to El Nino. This climate volatility, it didn't just break temperature records, it had a tangible, disruptive impact on renewable energy generation across the globe. It's a really clear signal that climate change is now directly influencing the very systems meant to combat it.
And this isn't just like an abstract idea. It gets really concrete, doesn't it?
Absolutely.
You might wonder, how exactly does this climate variability affect power generation? Well, take places like Sudan and Namibia. Hydropower output there plummeted by more than 50%. Dropped off a cliff.
50%. That's enormous.
Yeah, due to unusually low rainfall. Imagine the impact in Sudan, right? Rainfall was just 100 millimeters in 2023, less than half the long-term average.
Wow.
And this is a country where hydropower makes up something like 60% of their electricity mix.
So that's a massive disruption for millions of people, for the economy.
Exactly.
And these shifts, they weren't just confined to hydropower, were they? Wind energy, too, showed signs of stress under these changing conditions.
Right.
China, for instance, which holds, 40% of global onshore wind capacity?
Huge amount.
They saw only a...
But, okay, it's not all grim news, right? South America actually saw the scale tip the other way.
Oh, interesting. How so?
Well, countries like Brazil, Colombia, Bolivia, they experienced a 4 to 6% increase in solar generation.
An increase. Why?
Due to clearer skies and elevated solar radiation. More sun, basically.
Ah, okay. So climate variability cut both ways.
Exactly. This climate-driven bump, as they call it, meant roughly 3 terawatt hours of additional electricity. That's enough to power over 2 million homes for a year.
Wow.
So this unexpected solar boost, it's not just a silver lining. It kind of fundamentally shifts how we might think about designing future grids, doesn't it?
It really does.
Like, are we just designing to mitigate risk? Or can we actually design to leverage a dynamic climate sometimes?
That's a really interesting question.
And our sources say Europe is also seeing more days with high solar radiation, making solar power more efficient over time there too.
So the climate isn't just a threat, it's a direct, fluctuating variable we have to account for better or worse. Okay, so this brings us to a crucial point. Why are our renewable energy systems, which we think of as robust, sustainable, why are they so susceptible to these changes?
Yeah, what's the core issue?
Well, the core issue is that our infrastructure,
Yeah.
Our dams, solar farms, wind turbines. It was largely designed based on past climate patterns.
Ah, based on history.
Exactly. We've essentially built for a stable past, not this dynamic future where, variability is the new constant.
Okay, so if we're building on yesterday's climate data, what are the long-term consequences,
Mm-hmm.
especially for something like hydropower?
Right.
Dams rely on predictable seasonal flows, often from snowmelt or glacial runoff.
Mm.
Our sources quote experts like Roberta Boscolo from WMO, the World Meteorological Organization. She points out there will be a short-term boost in hydropower as glaciers melt.
Okay, more water initially.
But once those glaciers are gone, so is the water.
Yeah.
And that is irreversible, at least on human timescales.
Oof, irreversible.
Yeah, and we're already seeing this start to unfold in critical regions like the Andes and the Himalayas.
So if that meltwater disappears, entire countries could face severe long-term energy deficits with no easy alternative.
It's a huge potential problem.
And the vulnerabilities, they extend far beyond just water availability, right?
Seems like it.
A recent UN Environment Program report highlights that rising sea levels and stronger, more frequent storms pose growing risks to coastal energy facilities.
Like solar farms near the coast,
Yep.
substations.
Exactly. And think about increasingly intense wildfires, too. They can take down critical power lines, cause blackouts across huge regions.
Right, we've seen that happen.
And extreme heat, it's not just about increasing demand for air conditioning.
No.
It actually reduces the efficiency of solar panels. They don't work as well when they get too hot. And it puts immense strain on the grid infrastructure itself.
Wow.
Mrs. Boscolo even notes that some nuclear power plants have had to actually stop operations because they didn't have enough cooling water during heat waves.
So even nuclear isn't immune.
It's a systemic vulnerability. It touches really every part of our energy ecosystem.
That sounds like we're not just dealing with isolated incidents then. It sounds like a systemic challenge that needs a pretty radical overhaul of how we plan everything.
Absolutely.
From where we even put a solar farm to how we design a dam.
Precisely. I think the critical takeaway here is that when we design, build, and project power generation infrastructure, we have to genuinely think about what the climate of the future will be.
Not just the past.
Not simply what the climate of the past was. This shift in mindset, it's foundational for creating truly resilient systems, moving from just reacting to things towards proactive adaptation.
Okay, so if the past is no longer a reliable guide, where do we even start? How do we plan? Our sources point to this powerful solution: climate intelligence.
Right.
Sounds a bit sci-fi, but apparently it's very real and incredibly critical for our energy future.
It is. And what's really transformative about climate intelligence is its deep integration of climate forecasts, data, and scientific understanding into every level of energy planning.
So not just looking at historical averages anymore.
Exactly. Historically, energy planners relied on those averages, assuming a stability that, just doesn't exist anymore.
Right.
But now, as Hamid Bassani from WMO explains it, we need to know what the wind will be doing next season, what rainfall will look like next year, not just what it looked like a decade ago.
So looking forward.
It's about moving from reactive crisis management to proactive, data-driven adaptation, using forecasts much more strategically.
And this isn't just theory, right? It's actually making a difference in the real world already.
Oh, yeah, absolutely.
Like in Chile, hydropower generation surged by as much as 80% in November 2023. Huge jump.
80%.
Yeah, because of unusually high rainfall. Now, while that was climate-driven, advanced seasonal forecasting could potentially help dam operators anticipate events like that.
How?
Well, they could manage reservoirs more effectively, right? Store water, release it strategically, maybe prevent flooding downstream too.
Okay, makes sense.
Or imagine wind farm operators scheduling their maintenance during predicted low wind periods to minimize downtime. Or grid operators planning for energy spikes during anticipated heat waves or droughts. We now have forecasts that stand from like a few seconds ahead all the way to several months. Each has specific uses for optimizing energy management.
And technology is really supercharging this intelligence, isn't it? AI.
Yeah, artificial intelligence is playing a crucial role.
Machine learning models trained on huge amounts of climate and energy data, they can predict these resource fluctuations with much higher resolution and accuracy.
Okay.
These tools can optimize things like when to deploy battery storage or shift energy between regions, making the whole system far more flexible and responsive.
So using AI to manage the grid better.
Exactly. For example, in Costa Rica, there's an AI-based model for short-term wind speed forecasting. It's now integrated into their National Electricity Institute's platform, and it's actively optimizing wind farm operations right now.
That's a really clever application.
Yeah.
And AI is helping in other creative ways too, apparently, like in Chile again. Another project used AI to estimate evaporation rates on reservoirs that have floating solar panels on them.
Ah, photovoltaics.
Yeah. And the results showed that these floating panels can reduce water evaporation by up to 85% in summer. The national average saving was 77%.
Wow, so it's generating clean energy and conserving water?
Exactly. It's about combining multiple benefits through smart, data-driven decisions.
And if we connect this to the bigger picture, the promise, but also the challenge of this climate-smart renewable planning, it's particularly clear in the global south.
How so?
Well, take Africa. It has some of the best solar potential on the planet, right? Huge potential.
Absolutely.
Yet it holds only about 2% of the world's installed renewable capacity.
Only 2%. Why is that?
Well, a key reason, as Mrs. Boscolo from WMO points out, is a lack of observational data and investment.
Ah, the data gap.
Yeah, that makes it harder to create accurate forecasts, which in turn makes it harder to secure funding for these crucial projects.
So it's a cycle.
It is, and tackling this isn't just about climate mitigation. It's a massive development opportunity, bringing reliable energy, driving industrial growth, creating jobs.
So unlocking this future isn't just about the tech itself, but about sharing knowledge and data globally to bridge that gap.
Absolutely. Mr. Bastani highlights the huge untapped potential in data collected by the private sector.
From power plants.
Yeah, integrating historical and real-time observations from power plants of all kinds. Solar, wind, hydro, even nuclear that can significantly improve our weather and climate models.
So everyone benefits.
It's a true win-win scenario. Better reliability for energy companies, better models for climate scientists.
Okay, so beyond climate intelligence, what other sort of fundamental shifts are crucial for building this truly resilient, clean energy future?
Well, another critical action is diversification.
Don't put all your eggs in one basket.
Exactly. Relying too heavily on just one renewable source, like hydro or wind, can expose countries to big problems during seasonal shifts or long-term climate changes. In Europe, for example, energy planners are increasingly concerned about something called Dunkelflaut.
Dunkel what?
Dunkelflaut. It translates roughly as dark doldrums.
Okay.
It's basically a period, often in winter, with very little wind and very little sun, cloudy, still days.
Ah, so both solar and wind output drop at the same time.
Precisely. And this phenomenon really underscores the critical need for more energy storage batteries, pumped hydro, etc., and reliable backup power to fill those inevitable gaps.
So for energy planners and policymakers looking ahead, this means placing multiple bets, not just focusing on one technology.
Exactly. It means a diversified energy mix is absolutely essential.
What kind of mix?
One that includes solar, wind, hydro, definitely battery storage, and even other low-carbon sources like geothermal where it's available. Spreading the energy bets across different sources makes the entire system more resilient.
Especially as extreme weather gets more frequent and unpredictable.
For sure, it makes the whole system less vulnerable to localized problems or single-source disruptions. It's really about building a robust portfolio of energy sources.
You know, this whole deep dive really drives home the message that our planet is heading towards an electric future, isn't it?
Seems unavoidable.
Electric transport, electric cooking, electric heating. Having a reliable electricity system is just paramount for everyday life, for economic stability.
Absolutely crucial.
And it's genuinely inspiring to see organizations like Envision Racing embodying this drive, trying to accelerate the transition to clean energy and e-mobility through initiatives like their Race Against Climate Change.
Indeed. Their mission aligns perfectly with this need for resilient energy systems. They aren't just talking about it. They seem to be actively contributing to solutions.
How so?
Well, through initiatives that promote sustainable practices, pioneering clean technology, for example, you mentioned we had info from them, they created India's first race car made with e-waste.
Wow, really? E-waste?
Yeah. These kinds of efforts demonstrate that building a climate-smart energy future needs innovation and unwavering commitment from all sectors.
But it's not just governments or energy companies.
Exactly. It drives home the idea that the future isn't just about expanding capacity, building more stuff. It's about building systems that are inherently resilient, adaptable, and deeply informed by climate science.
What a journey through this intricate dance between climate change and renewable energy.
It really is intricate.
We've seen that while the clean energy revolution is definitely in full swing, it's not immune to the very forces it seeks to mitigate.
Not at all.
From plummeting hydropower in Sudan to boosted solar in South America and this critical need for climate intelligence and diversification. It's clear that designing for the future requires a profoundly new way of thinking.
Absolutely. The insights from organizations like the WMO and IRENA, alongside the proactive efforts we see from groups like Envision Racing, they remind us that knowledge is really most valuable when it's understood and actually applied.
Right. Not just known.
Exactly. We can't just build more. We have to build smarter. Integrating cutting-edge forecasting, AI, diversification, creating truly reliable and resilient energy systems. Systems that can not only withstand, but maybe even strategically leverage a dynamic climate.
So as you listening reflect on this deep dive, here's maybe a thought for you.
Mm-hmm.
If our planet is indeed heading towards this future where almost everything is electric,
Mm-hmm.
and our energy systems have to be designed not just for today, but for a dynamic, evolving climate.
Oh.
What kind of critical questions should you be asking about the energy infrastructure being developed in your own community right now?
Good question.
How can you help ensure that these systems are not just green on paper, but truly climate-proofed, ready for whatever tomorrow brings?